In this question, there are four masses which are kept in a corner of a square. So let's draw the square. Consider this is a square, and these are the four masses, and four are having equal mass. So let's consider the mass as m because it is given, and we'll assume the side length of the square is x. So that we need to find, and they have given the net force on one of the mass is to be 2 root 2 plus 1 by 32 into gm squared by l squared. So we know that gravitational force is attractive force. So if you have two masses, say for m1 and m2, if they are separated by a distance r, then the gravitational force between them given by g m1 m2 by r squared, and it is attractive force. So let's assume one of the masses. First we'll number it, like let this be 1, this is 2, 3 and 4. So we'll find the net force on the mass 1. So it will experience force due to the remaining masses. So this second mass will attract this in this way with the force F12. F12 means force on first mass due to the second one. Similarly, this one F13, and here this is F14. So now we'll write the magnitude of this forces. F12 magnitude, which is equal to G. We'll use this expression only, G m1 m2, since both are same. It's going to be gm squared by x squared, and this is equal to magnitude of F13. Okay, now if we'll write for F14 also, which is equal to gm squared by is going to be 2x squared. Here the distance between 1 and 4 is 2x. I'll explain how. We can use trigonometry. So this is a right angle triangle where both the sides are x. So the hypotenuse is going to be root 2x. So I'm using Pythagoras theorem. So if you use it, you will get this one. Okay. Now let's add this F12 and F13. So two forces are there. We are adding. There is a formula to add two forces or two vectors in general. If this is A vector, if this is B vector, if they are making angle theta, and so A vector plus B vector magnitude can be written as magnitude of A vector squared plus magnitude of B vector squared plus twice of magnitude of A magnitude of B cos theta. This is a basic thing in vector addition. So here, if we consider this F12 and F13, angle between them is 90 degree. So the third term in this addition will be 0. So we left with only first two terms. So let me write it. I'll put it as F123, which is the combination of F12 and F13, and I'm going to write magnitude of it. This is going to be magnitude of F12 square plus magnitude of F13 square. Since both of them are same, so I can write like this, twice of F12. So this is going to be equal to root 2 F12 magnitude. So this is F123. Okay, now if you look at the direction of this combination of two vectors, which is F12 and F13, it is going to act in this direction, which is along F14. So to find the net force, we can just add this F123 and F14. So F net, which is equal to F123 plus F14. So don't get confused, like somewhere I'm using this arrow mark, somewhere I'm not using. Here I'm trying to deal with magnitudes only. So that's why I'm not showing much interest on this sign. I'm explaining here. Fine. So now we'll just add both the magnitudes since the direction is same. I'll substitute here. This is root 2 F12 plus F14. So root 2 F12 is gm squared by x squared plus F14 is gm squared by here 2x squared. So if we look at the question, they have written something and multiplied with gm squared by l squared. So this gm squared by l squared, that one I just want to take it out. Gm squared by x squared, I take it out. Root 2 plus 1 by 2. So this will become gm squared by x squared into 2 root 2 plus 1 by 2. So this is the net force. And based on the question, this is equal to 2 root 2 plus 1 by 32. Let me check it. Yeah, by 32 into gm squared by l squared. Fine. So we can just cancel the numerator since both the sides are equal. Oh, sorry, it's not 32. Here it is 2 only. Yeah. So 32 L squared will become 2x squared. So x squared equal to 16 L squared. X equal to 4L. So length of the square is 4L.